Welcome to these gentle, soothing stories for sleep. I'm so glad you are here. Whether you are preparing to drift off to sleep, relaxing after a long day, or simply seeking a quiet companion, you've come to the right place. Tonight, we will embark on a journey into the very heart of a profound mystery, a concept that shapes our entire existence, yet remains beautifully elusive: the true nature of time. Before we begin, I'd love to know where you're listening from tonight, or how your day was. Please leave a comment below. Wherever you are, I hope you are feeling comfortable, relaxed, and ready to explore something gentle yet extraordinary. And if you find these soothing scientific journeys interesting, pleasant, or even just wonderfully weird, please consider liking this video and subscribing to the channel. It helps more souls who are searching for peace find their way here. Now, let us begin. Find a comfortable position and let your awareness settle. In the quiet of your room, as the world outside softens its voice, perhaps you can begin to feel it. A soft and muffled sound, a rhythm felt more than heard. It is the steady, faithful beat of your own heart, a gentle percussion that has been with you since before your first breath, a constant companion in the profound silence of your own being. This is our first and most intimate clock, the primordial drumbeat that measures out our lives in silent, pulsing waves. Let your attention drift to the feeling of the air as it enters your body, a cool and gentle tide, and the warmth of its release, a slow and calming ebb. Notice the almost imperceptible pulse in your wrist, or the side of your neck, a quiet river of life flowing just beneath the surface. Each beat, a tiny, present moment, a confirmation that you are here, now. This internal world operates on its own schedule, a symphony of rhythms that proceeds at its own unhurried and graceful pace, largely indifferent to the frantic demands of the clocks we have built on our walls and wrapped around our wrists. This is where our story of time must begin, not with the ticking of gears or the spinning of planets, but here, in the quiet, rhythmic universe that you carry within you. This profound internal timing is not merely a poetic idea. It is a deep biological reality, a field of study known as chronobiology. Every living thing on this planet, from the humblest algae to the most complex mammal, possesses an internal clock. We often call this the circadian rhythm, a name derived from the Latin words circa diem, meaning about a day. It is an ancient, evolutionary inheritance, a biological program that anticipates the 24-hour cycle of light and darkness on our rotating world. This rhythm is not a simple on-off switch for sleep and wakefulness. Rather, it is a vast and intricate orchestra of timing that governs nearly everything we do and are. It dictates the ebb and flow of our hormones, the rise and fall of our body temperature, the cycles of our metabolism, and even the sharpness of our minds. It is the reason we often feel a natural dip in energy in the mid-afternoon, and why our bodies instinctively know when it is time to rest and repair. At the very heart of this orchestra, seated in the hypothalamus, at the base of our brain, is the conductor. It is a tiny, elegant cluster of about 20,000 neurons, called the suprachiasmatic nucleus, or the SCN for short. Though it is no bigger than a grain of rice, this master pacemaker is responsible for sending out the signals that synchronize the countless cellular clocks operating in every organ and tissue of our bodies. Imagine a grand symphony orchestra where every musician has their own sheet music and their own sense of timing. Without a conductor, the result would be chaos. The SCN is that conductor, tapping its baton to ensure that the liver, the heart, the lungs, and the digestive system all play in harmony, creating the beautiful, coherent music of a healthy, functioning being. Scientists discovered the profound importance of the SCN through elegant experiments, where, if this nucleus was damaged or removed in animals, their regular cycles of sleep and activity would dissolve into a chaotic and fragmented pattern. They lost their internal anchor in time. What is perhaps most fascinating about this internal clock is that it is not perfectly tuned to our 24-hour day. If a person were to live in a deep cave, completely isolated from sunlight and all external time cues, their internal clock would continue to run, but it would drift. On average, the human free-running clock cycles at approximately 24.2 hours, It runs just a little bit slow. This means that, left to our own devices, we would gradually fall out of sync with the world outside, our internal day starting a little later each time the Earth completed a turn. This small but crucial imperfection reveals something profound. Our internal time is not self-sufficient. It is designed to listen, to be corrected, to be guided by a greater rhythm outside of ourselves. Our bodies are like a beautiful, antique timepiece that must be set each morning to the correct time. As we rest here, feeling that gentle internal river, we might ponder the very first rhythm we ever knew. Long before we were aware of the sun or the moon, we floated in the quiet warmth of the womb, and the first clock we experienced was the steady, rhythmic beat of our mother's heart. Perhaps this is where our sense of time was truly born, in that gentle, rocking cadence, a beat that set the stage for our own life's pulse and taught us, on the deepest possible level, that to exist is to be in rhythm. But if our internal clock runs on its own gentle rhythm, a rhythm that is almost, but not quite, in tune with the world, what is the great clock in the sky to which it must constantly listen? That great clock is announced by the first sliver of light painting the eastern horizon, a silent and magnificent announcement that our world is turning once more toward the warmth of its star. Imagine that moment, just before dawn, when the darkness is at its deepest, and the air holds a cool stillness. And then, it begins. Not as a sudden flash, but as a slow, graceful bloom of colour. The deep indigo of the night sky begins to soften at its edge, blushing with a faint violet, then a gentle rose, which slowly warms into a burnished orange. This light doesn't just arrive, it seeps into the landscape, gently waking the world. You can feel it as a subtle shift in the temperature of the air on your skin, a promise of the day's warmth to come. The first birds begin their tentative calls, their songs weaving into the growing light, creating a soundscape that is unique to this sacred time of day. This daily spectacle is perhaps the most profound and reliable clock we have ever known, a grand and beautiful timepiece available to every creature that has ever lived on this planet. It is the steady hand of the sun that keeps our own inner rivers flowing in time with the great ocean of the world around us. The fundamental unit of our day is, of course, a direct consequence of the elegant and unfaltering physics of our planet. The Earth spins on its axis at a steady pace of about 1,000 miles per hour at the equator, completing one full rotation in what we have defined as 24 hours. This majestic, silent turn is what creates the cycle of day and night. It is this cycle that our biology, as we explored, has so deeply internalized. The link between the grand celestial motion and our intimate inner workings is both simple and profoundly beautiful. It is light itself. That morning light, composed of countless particles called photons, travels across 93 million miles of space to enter our eyes. When these photons strike the retina at the back of the eye, they don't just allow us to see the emerging world, they trigger a specific neural signal. This signal travels along a dedicated pathway directly to our master clock, the SCN. This daily signal from the sun is what scientists in chronobiology call a Zeitgeber, a wonderful German word that translates to time giver or synchronizer. The morning light is the most powerful Zeitgeber of all, acting as the master signal that resets our slightly off internal clock each and every day, correcting that 24.2-hour drift and anchoring it firmly to the Earth's 24-hour rotation. It is the equivalent of taking out an old, beautiful pocket watch each morning and carefully winding it, adjusting its hands to the precise time. Without this daily act of synchronization, our inner sense of time would, within a few weeks, be completely out of alignment with our environment. We would find ourselves wanting to sleep when the world was bright and be wide awake in the dead of night. Our ancient ancestors understood this relationship with the sun, not through neuroscience, but through direct, lived experience. They built the first external clocks, sundials, to track its movement. A simple stick or stone, a gnomon, placed in the ground, would cast a shadow that crept across the earth, a dark finger tracing the passage of the hours. It was a way of making the invisible flow of time visible, of externalizing the great clock of the sky onto the ground at their feet, a silent and profound dialogue between humanity and the cosmos. As we lie here, It is a lovely thing to contemplate a simple shift in perspective. We often speak of the sun rising in the morning and setting in the evening, as if it is the active agent in this daily drama. But of course, the sun is relatively still, the great, stable heart of our solar system. It is we who are in motion. We are the ones who are turning. We don't watch the sun rise. We are on a world that is spinning gracefully to face its life-giving warmth. And in the evening, we are not watching the sun set. We are turning away from it, into our own shadow, for a period of quiet and rest. This subtle change in language reframes our relationship with the day. We are not passive observers of time's passage, but active participants in a grand cosmic dance, a silent, planetary pirouette that has continued for billions of years. Our bodies have learned the steps to this dance so perfectly that they anticipate every turn, every dip into shadow, and every return to the light. The daily turn is one powerful defining rhythm, but our lives are also shaped by a much grander lap around this same star, a journey that draws a much larger circle in the fabric of space-time. What story is told in that longer, seasonal breath of a year? That longer, seasonal breath of a year is a story told in the changing angle of the sun, the slow waltz of the Earth in its orbit. It is a rhythm that brings the bloom of spring, the deep green of summer, the melancholy gold of autumn, and the quiet slumber of winter. We feel this annual time in our bones, in our traditions, in the very food we eat. Yet there is another library of time, one we carry within us, that is far more personal and strangely elastic. Its shelves are not marked by days or seasons, but by emotions and meanings. You have felt this time, I am sure. It can be triggered by the faint, unexpected scent of rain on dry summer pavement, or a forgotten melody from a passing car that suddenly, without warning, dissolves the present moment and transports you back years, perhaps even decades. In an instant, you are somewhere else entirely. It is not just a thought, but a full, immersive experience, a ghost of a moment resurrected with all its sensory richness. You can feel the impossible warmth of a childhood kitchen, the specific, rough texture of a grandparent's loving hand, or hear the distant sound of friends laughing on a summer evening long since past. This is the world of psychological time, a landscape where the past is never truly gone, and the future is a constant whisper. In this inner world, time does not flow like a steady river. It pools and eddies, it rushes forward in a torrent, and sometimes it seems to slow down to a near-perfect stillness. We have all experienced this strange malleability of time. Think of a week spent on a wonderful vacation, filled with new sights and experiences. It can feel as if a month has gone by. Yet, a month of routine, unchanging work can vanish in what feels like a blink. The anxious minutes spent waiting for important news seem to stretch into an eternity, while hours spent lost in a creative passion can feel like mere moments. This is the profound difference between clock time, the objective, regular ticking measured by our devices, and psychological time, the subjective, rich, and often unpredictable story of time that our brain tells itself. Our minds are not passive recorders of a linear sequence of events. They are active weavers of experience, and the thread they use is time itself. Our brain's perception of time is deeply intertwined with the way it processes information and forms memories. The hippocampus, a beautiful seahorse-shaped structure deep within our brain, plays a crucial role in encoding our experiences into long-term memory. When we encounter something new, something that breaks our routine, our brain pays closer attention. It dedicates more resources to processing the novel information, capturing more details about the environment, our feelings, and our thoughts. This increased density of information processing has a curious side effect. When we look back on that period, our brain interprets the wealth of stored data as a sign that the event must have lasted for a longer duration. This is sometimes known as the oddball effect. If you see a series of identical images flashed before your eyes, and then one different, oddball image is shown for the exact same length of time, you will perceive the oddball image as having lasted longer. Your brain, surprised by the novelty, stretched the moment to take it all in, like a film director using slow motion to emphasize a critical, dramatic scene. Emotionally charged events work in much the same way. The fear felt during a near accident or the joy of a profound reunion causes our brain to kick into high gear, releasing adrenaline and searing the details of the moment into our memory with incredible vividness. In retrospect, these moments feel frozen, expanded, and timeless. So we are left with a beautiful question to ponder as we rest. Are we ever truly living in the present moment? Or are we always situated in a constantly shifting space between what has been and what might be? Our consciousness seems to be a place where the echoes of the past are constantly replayed and reinterpreted, while the possibilities of the future are endlessly rehearsed and imagined. Perhaps the now, that elusive moment we can never quite seem to grasp, is not a point on a line at all. Perhaps it is simply the delicate scene where the rich tapestry of our memory meets the shimmering, unwritten fabric of our imagination. Our minds can clearly stretch and bend time, twisting a second into an eternity and a year into a fleeting thought. But what about the physical world itself? Is this elasticity purely a product of our minds, or can time itself, the very time measured by unwavering clocks, actually be bent? To begin to answer that question, we must leave the inner world of the mind and turn our attention to something far older, something solid and patient and real. Imagine walking along a riverbank and reaching down to pick up a smooth grey stone from the water's edge. It feels cool and heavy and solid in your hand, its surface worn to a perfect smoothness by centuries, perhaps millennia, of the river's constant caress. This simple stone is a clock, a keeper of a time so vast it challenges our very ability to comprehend. It has rested on this earth through ages we can only dream of, a silent witness to the slow, grand, and inexorable passage of a time that is etched not in memories, but in the very substance of our world. To feel this time, we can imagine standing on the rim of the Grand Canyon, a place where the earth has been laid open like a great book. It is more than just a breathtaking sight. It is a library of stone whose pages are the deep, coloured layers of rock, each distinct stratum telling a story that is hundreds of millions of years old. The wind that echoes through its vast chasms seems to carry a whisper from another epoch, a time when strange seas covered the land and monstrous creatures walked where we now stand. This is the realm of deep time, the immense, almost unimaginable timescale of geology. It is a form of time that makes a human lifetime, or even the whole of human history, seem like a single grain of sand on an infinite beach. Scientists have learned to read this ancient story using remarkable techniques like radiometric dating. The principle is as elegant as it is powerful. Certain naturally occurring elements, like uranium or carbon-14, are unstable. Their atoms decay at a perfectly predictable rate, transforming into other, more stable elements over vast periods. Each of these radioactive elements has a half-life, the amount of time it takes for half of a given sample to decay. For carbon-14, this is about 5,730 years, making it useful for dating organic remains from our more recent past. For an element like uranium-238, which decays into lead-206, the half-life is about 4.5 billion years. By measuring the ratio of the original element to the decay product within a rock, scientists can determine its age with astonishing accuracy. It is like finding a magical hourglass within the stone itself, one that was turned over the moment the rock first cooled and solidified, and whose falling grains have been marking the passage of eons ever since. To even begin to grasp the scale of this time, let us use a familiar analogy. Imagine that the entire history of our Earth, from its formation some 4.5 billion years ago to this very moment, is compressed into a single calendar year. In this cosmic year, the Earth itself forms on January 1st. The first signs of simple, single-celled life do not appear in the oceans until late March. The Cambrian explosion, a frenzy of evolutionary creativity that gave rise to the ancestors of most modern animals, doesn't happen until mid-November. The dinosaurs, those great and terrible lizards, would appear on our calendar around Christmas Day, and they would roam the Earth for only a few days, before vanishing in the late evening of December 26th. The whole of recorded human history, from the first civilizations in Mesopotamia to the quiet moment you are experiencing right now, would occupy only the final 10 seconds before midnight on December 31st. Your own life, in this grand calendar, is less than the blink of an eye. The ground beneath our feet is not a static stage, but a dynamic and ever-changing testament to a story of unimaginable length. A story that makes our own brief lives seem both infinitesimally small and, at the same time, profoundly, heartbreakingly precious. If the Earth has a clock made of stone that tells a story billions of years long, what kind of clock governs the stars themselves, those distant points of light that have witnessed it all? The clock that governs the stars is written in a language of light and distance. To read it, we need only to go outside on a clear, dark night, far from the glare of city lights, and look up. There, arching across the heavens, you might see the faint, milky band of our own galaxy, a shimmering river of stars that is our home in the cosmos. It is a sight of such profound and quiet beauty that it can still the mind and open the heart. Each point of light in that river is a sun, many of them far larger and older than our own, and the light from them has travelled for thousands, even tens of thousands of years, to reach your eyes in this very moment. If you know where to look, you might even be able to spot a faint, fuzzy smudge of light in the constellation of Andromeda. This is the Andromeda Galaxy, the closest major galaxy to our own, and it is so far away that the light you are seeing tonight began its journey through the void some 2.5 million years ago. Think of that for a moment. When that light left its source, our distant human ancestors were just beginning their own journey on the plains of Africa. The light itself is a fossil, a ghostly messenger from the deep past, and your eye is the first thing it has touched at the end of its immense voyage. This is the key to understanding cosmic time, because light, though incredibly fast, travels at a finite speed, we can never see the universe as it is now. We only ever see it as it was. The speed of light is the ultimate speed limit of the cosmos. Approximately 186,000 miles per second. A light year is not a measure of time, but the immense distance that light can travel in 1 year. But in this fact lies a profound temporal truth. The farther away we look in distance, the further back we look in time. The night sky is not a static diorama, it is a layered museum of history. The light from our own sun takes about 8 minutes to reach us, so we are always seeing it as it was 8 minutes ago. The light from the nearest star system, Alpha Centauri, is over 4 years old. Many of the bright stars you see in the sky are hundreds or thousands of years in the past. When you look at the stars, you are quite literally looking into a time machine. With powerful telescopes, we can push this journey deeper and deeper into the past. We can see galaxies so distant that their light has been travelling towards us for billions of years, showing us what the universe was like when it was much younger, a more chaotic and fiery place. And we can go even further back than that. If we look not with visible light but with microwaves, we can see the oldest light in the universe, a faint, uniform glow that permeates all of space. This is the cosmic microwave background radiation, and it is nothing less than the afterglow of the Big Bang itself, the first light that was able to travel freely through space once the universe had cooled enough, about 380,000 years after its birth. It is a baby picture of our universe, a snapshot from nearly 13.8 billion years ago. Listening to this faint cosmic hum is like standing in a vast canyon and hearing the faint lingering echo of a monumental shout that happened long, long ago. As you rest here, under your own ceiling, you can imagine that vast, dark ceiling of the night sky above you. It is a beautiful and humbling thought that this entire celestial sphere is a window into the past. We are forever bound to see the cosmos not as it is, but as it was, with each star and galaxy representing a different then. We are, in a very real sense, living in the history of the universe, surrounded by the ghosts of ancient light. We have seen how we can measure time through the rhythms of our bodies, the turning of our planet, the decay of atoms in a stone, and the light from distant stars. But all of this measurement, from the heartbeat to the cosmic calendar, rests on a simple and intuitive assumption. That time is a constant, a universal drumbeat that is the same for everyone and everything. But is that truly the case? What if time is not a single, universal river? What if it flows differently for everyone? To explore that remarkable question, let us first appreciate the idea that for most of human history felt like an unshakable truth. Imagine a perfectly crafted antique pocket watch, perhaps made of polished silver or warm, glowing brass. You can feel its smooth, satisfying weight in your palm. Opening the cover reveals a face of pristine white enamel, with elegant black numerals and impossibly fine hands. Through a small window, or perhaps by turning it over to its crystal backing, you can see the inner world of the watch. A miniature universe of tiny, intricate gears, spinning flywheels, and a single, pulsing heart, the balanced spring, vibrating with flawless precision. Each component works in perfect harmony. Each tick and each tock a testament to order, predictability, and certainty. This beautiful machine is a perfect metaphor for the way we once understood the entire cosmos. As a grand and elegant clockwork, governed by laws of absolute precision. This sense of mechanical certainty is all around us in the world of the familiar. Think of the steady, comforting motion of a grandfather clock's pendulum, swinging back and forth, measuring out the seconds with a rhythm you can depend on. Or consider the reliable orbit of the moon around the Earth, a celestial dance so predictable that we can chart its phases and eclipses centuries into the past and future. There is a deep comfort in this predictability, a sense that the universe is not chaotic and random, but is instead a rational, understandable, and orderly place. This very feeling of a clockwork universe was the cornerstone of one of the greatest revolutions in human thought, brought to us by the mind of Sir Isaac Newton. In his monumental work, Newton laid out the laws of motion and universal gravitation, but underpinning all of it was a foundational concept of time. For Newton, time was absolute, true, and mathematical. He believed that time flowed at a constant rate, of itself, and from its own nature, without relation to anything external. It was a single, mighty, and invisible river flowing in one direction, at one constant speed, throughout the entire universe. All events, everywhere, took place against this universal, unchanging backdrop. My now was exactly the same as the now for a person on the other side of the world, and it was the same now for a hypothetical being in the Andromeda galaxy. This concept of absolute time was incredibly powerful and successful. It allowed Newton and the scientists who followed him to describe the motions of the planets, the path of a cannonball, and the fall of an apple with unprecedented accuracy. The universe, it seemed, really was a magnificent clock, and we had discovered its gears. There is a profound philosophical comfort in this idea. It gives us a shared, objective reality, a common stage upon which all our lives unfold. It means that we are all synchronized to one great, cosmic metronome. My present moment is your present moment. We are all moving through time together, a great procession carried along by that single, universal river. For centuries, this idea was the bedrock of physics, an assumption so fundamental that it was barely even questioned. It is intuitive, it is elegant, and it feels right. It is the time of our everyday experience, the time of our clocks and our calendars. But is this clockwork dream, this vision of a single, universal time, really true? What happens to the flow of time if you could build a ship that could travel so fast, you could almost outrun the light streaming from the clock's very face? What would that clock look like then? That very question, what happens to time when you travel at incredible speeds, was the key that unlocked a revolution in our understanding. A revolution that took place not in a laboratory with gears and pendulums, but in the quiet, creative mind of a young Albert Einstein. To begin to grasp his beautiful and strange idea, let us imagine two twins, both perfectly identical, both with watches synchronized to the very same second. One twin remains here on Earth, while the other boards a fantastically advanced spaceship and embarks on a long journey to a distant star, traveling at a speed that is very close to the speed of light. The spaceship eventually turns around and returns to Earth. When the traveling twin steps out of the ship, what will the two of them find? Our intuition, built on Newton's clockwork universe, tells us they should both have aged by the same amount. But this is not what happens. The twin who traveled through space would be significantly younger than the twin who stayed at home. This is not science fiction. It is a direct consequence of the way our universe is woven together. To understand why, we can begin with a more familiar sensation. Imagine yourself on a smoothly moving train, gliding through the countryside. As you look out the window, The world outside seems to blur past you, the trees and houses streaking by. Your motion has fundamentally changed your relationship with the world outside the train. Now, imagine that train is moving faster and faster, approaching the unimaginable speed of light itself. Einstein's genius was to start with two simple but powerful ideas, or postulates. The first is that the laws of physics are the same for everyone who is in uniform motion. Your experience inside that smoothly moving train is just as valid as the experience of someone standing on the platform. The second idea is the strange one. The speed of light in a vacuum is the same for all observers, no matter how fast they are moving. This is where our intuition begins to break down. If you are on that train and shine a flashlight forward, you might think that someone on the platform would measure the speed of that light beam as the speed of the train plus the speed of the light. But they would not. They would measure its speed as simply the speed of light, exactly the same speed that you would measure from inside the train. This constant, unvarying speed of light is the bedrock of Einstein's special theory of relativity, and it leads to a staggering conclusion. If the speed of light is constant for everyone, then something else must change to compensate for an observer's motion. That something else is time. Einstein realized that space and time are not separate things, but are instead two aspects of a single, unified fabric. Space-time. The faster you move through the 3 dimensions of space, the slower you move through the 1 dimension of time. Motion through space comes at the cost of motion through time. So for our spacefaring twin, rocketing through the cosmos at nearly the speed of light, their personal, internal clock and every physical process in their body and on their ship was ticking much, much more slowly than the clock of their twin back on Earth. When they return, only a few years might have passed for them, while decades have gone by for the world they left behind. This effect is known as time dilation, and it means that the beautiful, universal clock of Newton was an illusion. We must let go of the comforting idea of a single, mighty river of time. Instead, the universe is filled with countless different streams and currents. Time is not absolute, it is personal. Each of us, in a very real sense, carries our own clock, and the rate at which that clock ticks is dependent on our own unique journey through space-time. For the most part, our speeds relative to one another here on Earth are so small that the differences in our rates of time are infinitesimal, too small to ever notice. But they are real. Every time you take a walk or ride in a car, your personal clock ticks just a fraction of a nanosecond slower than that of someone standing still. Time, it turns out, is not the rigid, unchanging backdrop we once imagined, but a fluid, malleable, and personal experience. If our very own motion through space can warp and slow the passage of our time, what then of the fabric of space itself? What does a force like gravity do to the river of time? To explore that question, let us begin with a feeling that is with you always, a silent and constant companion in your life. The simple, ever-present sensation of gravity. It is the feeling of your own weight, the gentle but firm pressure that holds you to your bed or your chair. For Newton, this was a mysterious force, an invisible tether reaching out across space to pull objects toward one another. But for Einstein, gravity was something far more profound and beautiful. It was not a force at all, but a consequence of the very shape of the universe. To picture this, imagine you have a large, thin sheet of rubber that has been stretched out perfectly flat and taut, like a trampoline. This flat sheet represents the fabric of space-time in an empty universe. Now, take a heavy bowling ball and place it in the center of the sheet. The ball's weight will cause the rubber to curve and warp, creating a deep depression, a well, in the fabric. This is what mass does to space-time. Now, if you take a small marble and try to roll it in a straight line past the bowling ball, you will find you cannot. The marble's path will be bent by the curvature of the sheet, and it will spiral inward toward the heavier object. This is gravity. This was the central insight of Einstein's general theory of relativity. Mass and energy tell space-time how to curve, and the curvature of space-time tells matter how to move. Gravity is the geometry of the universe. An object like our sun is a massive bowling ball sitting in the fabric of space-time, and the Earth is like the smaller marble, not being pulled by a force, but simply following the straightest possible path through the curved space around the sun. This is why planets orbit stars. But this curvature doesn't just affect the three dimensions of space, it also, crucially, affects the dimension of time. And this leads to another form of time dilation, one that is even stranger than the effect of speed. Time itself runs slower in stronger gravitational fields. The deeper you are within a gravitational well, the slower your clock will tick relative to someone farther out. This is not a theoretical fantasy. It is a measurable and essential fact of our modern world. A clock placed at sea level, where gravity is slightly stronger, will genuinely run a tiny bit slower than an identical clock placed on top of a high mountain. The difference is impossibly small for our human senses, but it can be measured by our most precise instruments, atomic clocks. The most profound and practical example of this is the Global Positioning System, or GPS, that many of us use every day. The GPS network relies on a constellation of satellites orbiting high above the Earth. These satellites carry incredibly precise atomic clocks, but these clocks are subject to two relativistic effects. First, because they are moving very fast in their orbits, special relativity predicts their clocks should tick slightly slower than ours on the ground. Second, because they are far away from the Earth, in a weaker gravitational field, general relativity predicts their clocks should tick slightly faster than ours. The gravitational effect is actually the stronger of the two. If the engineers who designed the GPS system did not account for both of these effects of relativity, the system would be utterly useless. The tiny errors in timing would accumulate so rapidly that the positions they calculate would be off by several miles within a single day. The fact that your phone can tell you where you are with remarkable accuracy is daily, tangible proof that time is not absolute. It is a truly wondrous thing to contemplate. Every object that has mass, our sun, our Earth, the moon, even your own body, is creating its own tiny, gentle depression in the fabric of space-time. We are all living within the subtle gravitational ripples of the world around us, and these ripples are subtly altering the flow of our personal time. We are all, in our own small way, warping the universe around us. If time can be warped by the gentle gravity of our planet, and more so by the immense gravity of our sun, what happens when gravity becomes so extreme, so powerful, that the curvature of space-time becomes almost infinitely deep? What happens to the passage of time at the edge of a black hole? To approach the edge of a black hole is to approach the place where our understanding of time and space breaks down completely, where the river of time flows over an infinite waterfall. So let us imagine this journey, not with fear, but with a sense of profound wonder. Imagine yourself as a traveller in space, falling gently toward one of these cosmic behemoths, an object with gravity so immense that it has crushed itself out of existence, leaving behind only a warped abyss in the fabric of space-time. From a safe distance, a friend watches your journey through a powerful telescope. As you get closer and closer to the black hole, your friend would notice something extraordinary. You would appear to be slowing down. Your movements would become more and more sluggish, as if you were moving through invisible molasses. The light from your spaceship would become stretched by the intense gravity, shifting towards the red end of the spectrum, becoming dimmer and dimmer. As you reach the edge, a boundary known as the event horizon, you would seem to your friend to freeze completely, a faint, reddish, static image of you suspended at the brink for all eternity. From their perspective, you would never, ever cross. The event horizon is the black hole's point of no return. It is not a physical surface, but an informational boundary. It is the point where the gravitational pull becomes so strong that the escape velocity exceeds the speed of light itself. Since nothing can travel faster than light, nothing that crosses the event horizon can ever get back out. From your friend's distant, safe perspective, the intense gravity of the black hole has caused your time to dilate infinitely. Your clock has, from their point of view, slowed to a complete stop. An eternity of their time would pass in the single moment you seem to hover at the edge. But what about your own experience? What would you feel? The astonishing truth is that, for you, nothing special would happen at all as you crossed the event horizon. Your watch would continue to tick at its normal rate. Your heart would beat with its steady rhythm, and your thoughts would flow as they always do. You would slip across this invisible boundary in a finite and unremarkable amount of time, completely unaware that you had just passed the point of no return. The true strangeness would begin after you had crossed. Inside the event horizon, the curvature of space-time is so extreme that the roles of space and time effectively switch. Outside the black hole, you are free to move in any direction in space, forward, backward, left, right, but you are forced to move ever forward in time. Inside the black hole, this is reversed. You are now forced to move in only one direction in space, inexorably toward the center, the singularity, and you can move through time with the same freedom you once had in space. And in the moments before you reach that center, a final, spectacular vision would unfold. Because your time is now passing so differently from the time in the rest of the universe, you would be able to witness the entire future of the cosmos flash before your eyes in an instant. You would see stars being born and dying, galaxies evolving, and perhaps even the universe itself growing old and cold, all in the few moments that remained of your own time. We are left with a profound and unanswerable question. Your friend, watching from afar, sees you frozen for eternity at the edge of the black hole. You, in your own experience, cross the boundary and fall to the center in a finite amount of time, which is the real time. The universe, it seems, allows for both experiences to be true simultaneously. Time is so deeply relative that an eternity for one observer can be a fleeting moment for another. We have seen time as something personal, something relative, something that can be stretched and warped by speed and gravity to the most extreme imaginable limits. But in our own, everyday lives, on our gentle planet, time seems to behave in a much simpler way. It seems to move in only one direction, from the past, through the present, and into the future. Why? Why does the river only flow one way? What gives time its arrow? To find the source of that arrow, we can look not to the extremes of the cosmos, but to the most humble, everyday experiences. Picture a beautiful ceramic teacup sitting on a table. You can easily imagine the sequence of events that brought it there. The clay being shaped, fired, and glazed. Now, imagine it slipping and falling to the floor, shattering into 100 tiny pieces. This scene feels natural, familiar, and irreversible. You will never, in all your life, witness the opposite happen. You will never see a pile of broken shards on the floor spontaneously gather themselves together and leap back onto the table to form a perfect teacup. There is a deep and fundamental directionality to events in our universe. An egg can be scrambled, but not unscrambled. A drop of ink can dissolve in a glass of water, but the cloudy water will not separate back into a clear liquid and a perfect, tiny sphere of ink. This one-way street for physical processes is perhaps the most fundamental way we experience the passage of time. This intuitive feeling of time's direction is described by one of the most powerful and fundamental laws in all of physics, the second law of thermodynamics. This law deals with a concept called entropy, which, in simple terms, can be thought of as a measure of disorder, randomness, or chaos. The second law states that in any closed system, one that doesn't exchange energy or matter with its surroundings, the total amount of entropy will always tend to increase over time, or at best, stay the same. It never goes down. The universe as a whole is the ultimate closed system, and so its total entropy is always increasing. Things move from a state of order to a state of disorder. The shattered teacup is in a state of higher entropy, more disorder than the whole teacup. The murky, ink-infused water is in a state of higher entropy than the separated ink and water. The universe itself, it seems, began in a state of incredibly low entropy, a highly ordered and condensed state at the moment of the Big Bang, and it has been moving toward a state of greater and greater disorder ever since. This relentless increase in entropy is what gives time its forward direction. The arrow of time is simply the arrow of increasing entropy. It is not a fundamental law of motion for any single particle. The laws of physics work just as well forwards as they do backwards for a single atom, but a statistical law that governs the behavior of large collections of things. It is all about probability. To understand this, imagine you have a brand new deck of playing cards. perfectly ordered by suit and number. This is a very low entropy, highly ordered state. Now, give the deck a shuffle. The cards will become mixed into a random, disordered sequence. This is a high entropy state. It is incredibly easy to go from the ordered state to a disordered state. But imagine trying to unshuffle the cards, trying to get them back to their original, perfect order, just by randomly shuffling. It is not technically impossible, but it is so fantastically improbable that you could shuffle for the entire age of the universe and never expect to see it happen. There are countless ways for the cards to be disordered, but only one way for them to be in that perfect, original order. The universe behaves in the same way. It always moves toward the most probable state, and the most probable state is always one of greater disorder. This can feel like a pessimistic idea, this slow, inevitable march toward cosmic chaos. But there is a beautiful and poignant way to reframe it. As you lie here, you are a living, breathing testament to a temporary and local rebellion against this cosmic tide. Life itself is a pocket of incredible order and complexity. Your body takes in disordered energy and matter from your environment and transforms it into the highly ordered structures of your cells, your tissues, your very consciousness. You are a fleeting island of low entropy in a vast ocean of increasing disorder. Is life, then, a beautiful temporary defiance of the second law? A process that creates fleeting beauty and order at the expense of creating a little more disorder in the universe around it. If the universe's time is defined by this slow march towards disorder, are there other arrows of time we can perceive? Arrows that feel even more personal to us? What about the arrow of our own thoughts? That question of the arrow of our own thoughts brings us back, once more, into the intimate and familiar landscape of our own minds. There is a simple and undeniable feeling, a piece of knowledge so fundamental to our experience that we rarely even think to question it. You know the past, but you do not know the future. You have memories, perhaps vivid and detailed, of yesterday, of last year, of your childhood. But you have no memories of tomorrow. The future is a realm of possibility, of hope, of fear, of anticipation, but it is not a realm of knowledge. This powerful, one-way orientation of our consciousness is what we can call the psychological arrow of time, and it feels completely distinct from the shattering of teacups or the shuffling of cards. And yet, what if it is not distinct at all? What if it is, in fact, the very same arrow, experienced from the inside? To feel the truth of this, consider the different textures of your own mental states. When you call to mind a memory, a nostalgic moment from your past, it arrives as a landscape that has already been mapped. It has colours, emotions, and details that are fixed, even if they are hazy. It is a country you can revisit. But when you think about the future, you are standing at the edge of an open, unmapped field, often shrouded in a gentle fog. You can project possibilities onto it. You can imagine paths that you might take, but its details are not yet written. The feeling of remembering is fundamentally different from the feeling of anticipating, and this difference, this one-way flow from the known to the unknown, is the engine of our conscious narrative. We seem to live on the crest of a wave, with the vast ocean of the past behind us and the misty expanse of the future before us. For a long time, this psychological arrow was considered a matter for philosophy or psychology alone. But a deeper physical understanding suggests that it is inextricably linked to the thermodynamic arrow of time we just explored. The connection is as subtle as it is profound. The process of forming a memory in your brain is a physical process. Your neurons must build new connections, synthesize proteins, and store information in an ordered pattern. In short, to create a memory is to create a small, localized pocket of order within the brain. And as the second law of thermodynamics tells us, creating order in one place always requires the expenditure of energy. And this expenditure inevitably increases the total amount of disorder, or entropy, in the universe as a whole. Your body must burn calories, which releases heat into your environment, to power the neurological machinery that records your experiences. So, the very act of remembering, the process that allows you to know the past, is an entropy-increasing process. It is an act that is fully compliant with the one-way direction of the thermodynamic arrow. We remember the past and not the future, because the past is the direction in which the entropy of the universe was lower. Our minds, as physical systems, are fundamentally bound to this one-way street of cause and effect, of order giving way to disorder. Our conscious experience of time's ceaseless forward flow is not some trick of the mind or a purely psychological illusion. It is a direct and intimate reflection of the most fundamental laws that govern energy and matter throughout our cosmos. We feel time's arrow in the very structure of our thoughts, because our thoughts themselves are a part of that arrow's flight. We are physical beings, woven from the same fabric as the stars and the galaxies. And so the great story of the universe, its slow and irreversible unfolding from a state of perfect order, is also the story of us. So far, in our journey, we have treated this unfolding, this flow of time, as a smooth and continuous current, like a river without ripples. But what if we were to look much, much closer, at a scale smaller than any microscope can see? Does time still flow like a river, or does it, perhaps, tick? To explore this question, let us begin with an image from our own technology. Imagine you are watching a film. On the screen, a person walks smoothly across a room. A bird glides effortlessly through the sky. A wave curls and breaks upon the shore. The motion appears perfectly fluid, seamless, and continuous. And yet, we know that this is a carefully constructed illusion. If we were to examine the film strip itself, we would find that it is composed of a long series of individual, static frames. The appearance of smooth motion is created by projecting these still images in rapid succession, so fast that our eyes and brain blur them together into a coherent flow. Could the universe itself be constructed in the same way? Could time, which feels so much like a continuous river, actually be a sequence of tiny, discrete, and indivisible moments, clicking forward one after the other? We can feel the difference between these two ideas of time in the clocks we have built. Picture the face of an old, analog watch with a long, slender second hand. It seems to glide around the dial in a single, unbroken sweep, a perfect picture of continuous motion. Now, contrast that with the display of a digital clock. The seconds do not glide, they click over. The number 58 vanishes and is instantly replaced by the number 59. There is no in-between. Each second is a discrete, separate event. For most of our history, we have assumed that the universe works like the analog watch, that time is a smooth and continuous quantity that can be divided into ever smaller and smaller intervals, infinitely. But modern physics, in its deepest explorations of reality, has begun to suggest that the universe might, at its most fundamental level, be more like the digital clock. This idea comes from the meeting of our two great theories of the universe. General relativity, which describes the large-scale world of gravity and space-time, and quantum mechanics, which describes the strange, probabilistic world of the very small. When physicists try to unify these theories, they run into a problem at incredibly small scales. Below a certain fundamental limit, our current understanding of physics simply breaks down. This limit gives us what is known as Planck time. Named after the physicist Max Planck, it represents the smallest possible unit of time that has any physical meaning. It is an astonishingly short interval, approximately 10 to the power of negative 43 seconds. It is the time it would take a particle of light, a photon, to travel a distance known as the Planck length, the smallest possible distance. To write this number out would be a decimal point, followed by 42 zeros, and then a 1. It is a duration so infinitesimally brief that it is to 1 second what 1 second is to the entire age of the universe. Below this fundamental scale, the very concepts of time and space as we know them may cease to exist. Some theories of quantum gravity, such as loop quantum gravity, take this idea a step further. They propose that the fabric of space-time itself is not smooth and continuous, but is actually quantized, meaning it is made of tiny, indivisible, discrete units, like pixels on a screen. If this is true, then time does not flow. It ticks. The universe progresses in a series of incredibly rapid, distinct snapshots, each one separated by a single unit of Planck time. Motion from one place to another would not be a smooth glide, but a series of unimaginably tiny jumps from one frame of reality to the next. What we perceive as the smooth river of time would be an illusion, created by the immense number of these frames that flash by every single second. As you rest here, in the stillness of this moment, which feels so seamless, it is a profound thought that your very existence might be proceeding in a series of tiny, frozen, quantum steps. If this is true, it opens up a host of beautiful and mysterious questions. If reality is a series of frames, what happens in the gaps between the ticks? This granular, pixelated view of time comes from the strange world of quantum mechanics, a world of probability and uncertainty. How does this strange quantum world perceive the very idea of now? That strange quantum world, with its granular, ticking time, forces us to look again at an idea we take completely for granted, the present moment. So, I invite you to ask yourself a simple question. What is the now? Try to hold it in your mind. As soon as you grasp it, as soon as you think the word now, that moment is already gone, already a memory, already slipping into the past. The present is an impossibly thin and elusive boundary, the ghost that vanishes the moment you turn to look at it. We feel its presence so powerfully, it is the only time we ever truly seem to inhabit, and yet it has no duration. It is the knife's edge between the vast, settled country of the past and the undiscovered territory of the future. To feel its shimmering, transient nature, we can imagine standing on a beach, watching the waves roll in. You can see the dark, swelling shape of the next wave approaching from the sea. This is the future. And you can see the smooth, wet sand and glistening foam left behind by the last wave. This is the past. But the present moment, the now, is the infinitesimal, shimmering line where the wave curls and breaks, a line of chaotic, beautiful energy that is ceaselessly being born and ceaselessly dying in the very same instant. This slippery nature of the present moment is not just a poetic or philosophical puzzle. It is one of the deepest problems in all of physics. Our journey with Einstein showed us that there is no such thing as a universal now. Because of the finite speed of light, and the way time is warped by speed and gravity, two people in different places or moving at different speeds will not be able to agree on a single, simultaneous moment across the universe. My now is strictly local to me, and yours is local to you. An event that I see as happening now on Mars, someone on Mars would have seen as happening in their past. This lack of a universal present led some physicists and philosophers to a stunning and profound interpretation of the nature of time, an idea often called the block universe. In this view, the common sense idea that the past is gone, the future is yet to be, and only the present is real, is a grand illusion. Instead, the block universe model suggests that the past, the present, and the future all exist simultaneously and are equally real. Time is treated as a fourth dimension, just as real and explorable, in principle, as the three dimensions of space. The easiest way to visualize this is to imagine time as a loaf of bread. Each slice of the loaf is a now, a complete snapshot of the entire universe at one particular instant. Our past is the collection of slices behind our current one, and the future is the collection of slices yet to come. But in this view, all the slices already exist. The entire loaf, the whole of space-time, from the Big Bang to the final fading of the last star, is a single, existing, four-dimensional block. We, with our consciousness, are not actually moving through the loaf of bread. Rather, our awareness simply illuminates one slice after another, giving us the powerful but illusory feeling of time's passage, much like a single frame of a movie being lit up by a projector's lamp. This is a strange, beautiful, and perhaps unsettling thought. As you lie here, this interpretation suggests that the moment of your birth and every moment you have ever lived still exists, frozen in the block of space-time. And more than that, every moment you will ever live your future joys, your future sorrows also already exists, waiting for your consciousness to arrive and illuminate it. If this is true, it brings us to one of the deepest philosophical questions of all. If the future already exists, written into the fabric of the cosmos. What does that mean for our idea of free will? Are we truly making choices that shape our destiny, or are we simply actors reading our lines from a cosmic script that has already been written, from the first page to the last? The block universe is one powerful interpretation, born from the physics of relativity. But what if the future is not yet written? What if the strange rules of the quantum world offer us a different, more open-ended, and perhaps more hopeful picture of time? Let us leave that fixed, crystalline block of time behind for a moment and turn to that other possibility. At every moment of your life, you are faced with a choice. It may be a large one, or it may be as small as the choice to turn left instead of right on a walk, to speak a kind word or to remain silent. You make your choice, and your life proceeds down one path. But have you ever wondered, in a quiet moment, what happened to the path you did not take? In the clockwork universe of Newton, or the block universe of Einstein, that other path is simply a ghost, a possibility that never was. But in the strange and wonderful world of quantum mechanics, that unchosen path may be just as real as the one you are on. To picture this, imagine yourself standing at the entrance to a vast, misty forest. The path ahead of you immediately splits into two. You choose one and walk a little further, and that path splits again. And those paths split again and again, creating an infinite, branching network of possibilities, all disappearing into the soft, grey fog. This is the garden of forking paths. This idea grows out of one of the central mysteries of quantum mechanics. At the subatomic level, the world is a fuzzy, probabilistic place. Before we measure it, a particle like an electron does not have a definite position or a definite speed. Instead, it exists in what is called a superposition, a ghostly blend of all its possible states at once. It is in many places at the same time. It is only when we, the observers, perform a measurement when we look at the particle that its cloud of possibilities seems to collapse into one single, definite reality. The electron suddenly appears in one specific place. For decades, physicists wondered what was so special about the act of measurement that it forced reality to make a choice. In the 1950s, a physicist named Hugh Everett proposed a radical and beautiful alternative. He suggested that the particle's reality never collapses at all. Instead, the entire universe splits. This is the foundation of what is now called the many worlds interpretation of quantum mechanics. In this view, every time a quantum event has more than one possible outcome, the universe itself branches into multiple copies. In one branch, the event turns out one way. In another branch, it turns out the other way. All possibilities are realized. So when you measure the electron, the universe splits in two. In the universe you find yourself in, the electron is here. But in another, perfectly real universe, a copy of you finds that the same electron is over there. This branching happens constantly, with every quantum interaction everywhere in the cosmos, creating an unimaginably vast and ever-growing tree of parallel realities. There is no longer a single timeline, a single river of time. Instead, time itself is a constantly branching structure, a great cosmic tree growing new limbs with every passing moment. If this is true, it changes everything. It means that every choice you have ever made, every fork in the road you have ever taken, has been explored. When you chose to turn left, a version of you in another universe chose to turn right, and their world is just as real as yours. Somewhere, in another branch of the great cosmic garden, a version of you is living out the consequences of every decision you ever pondered but did not make. This is not a story of ghosts or alternate dimensions in a fictional sense, but a profound suggestion that reality is infinitely larger and more wondrous than what we perceive in our single branch. Time, in this view, is not a single line stretching from past to future, but a magnificent, endlessly creative, branching tree of possibilities, where every potential future is realized somewhere. Whether time is a single, solid block, or a constantly branching, living tree, both ideas seem to depend so much on us, the observers, and on the very act of measurement and consciousness. So how much of what we call time is a fundamental property of the universe, and how much of it is a beautiful and intricate story that we are telling ourselves? That question, how much of time is a story we tell ourselves, brings our grand cosmic journey right back to its starting point. The quiet, mysterious universe between our own ears. To feel the truth of this, think for a moment about the simple act of listening to a beautiful melody. You do not experience it as a random sequence of individual notes, one after another, each one separate and isolated. Instead, your mind effortlessly weaves them together into a coherent phrase, a flowing line of music that has a beginning, a middle, and an end. You hear the relationship between the notes, the rhythm they form, the emotional arc they create. The melody only exists because your mind is holding the notes of the recent past and anticipating the notes of the immediate future, binding them all together into a single, meaningful, present experience. Where does this remarkable cohesion come from? It comes from the silent, tireless work of the storyteller in your skull. This process is happening all the time, in everything we do. Consider the experience of watching a film. You perceive a continuous story, a world filled with characters who have motivations and desires, a plot that unfolds through a seamless flow of action and dialogue. But what are you actually seeing? You are really just being presented with a rapid sequence of still, silent images, 24 of them every second, accompanied by a separate track of sounds. It is your brain that performs the incredible magic trick of stitching these fragmented inputs together. It fills in the gaps between the frames to create the illusion of motion. It synchronizes the sound of a voice with the movement of a pair of lips. It constructs a rich, emotional, and temporal narrative from a stream of fundamentally disconnected data. Your brain is the director, the editor, and the audience, all at once, and the story it is constantly producing is your very experience of a flowing, coherent reality. Neuroscience is beginning to reveal how this grand illusion is constructed. Our sense of now is not an infinitesimal point, but what the psychologist William James called the specious present. It is a short window of time, lasting for perhaps a few seconds, within which our brain gathers up sensory information and binds it together into a single, unified experience. This binding is a far more complex task than it might seem. The information from your eyes reaches your brain at a different speed than the information from your ears, and both are different from the speed of a sensation of touch from your hand. If you were to experience these signals as they arrived, the world would be a confusing, disjointed mess of sights, sounds, and feelings that were slightly out of sync. Your brain, therefore, is constantly editing reality, collecting all the data from a small window of time, and then presenting it to your consciousness as a single, synchronized moment. You are never experiencing the world in true real time. You are always living in a very recent past that your brain has beautifully and seamlessly reconstructed for you. More than this, your brain is a magnificent prediction machine. It is constantly using the vast library of your past experiences to make its best guess about what is happening now and what is most likely to happen in the next moment. The feeling of time's smooth forward flow may be the feeling of this narrative being written, the continuous hum of your mind telling itself the story of you. As you rest here, feeling the rhythm of your own breath, it is a profound and gentle thought to entertain. Perhaps time, the great river we have been exploring, with its strange currents and deep eddies, does not truly exist out there in the universe in the way we experience it. Perhaps the past is only a trace in our memory, and the future is only a projection of our imagination. And perhaps the flow itself, that powerful sense of passage from one to the other, is the ultimate act of storytelling. A beautiful and necessary narrative woven by our minds to make sense of a universe of shimmering, quantum uncertainty. If our most intimate experience of time is a story, then what is the source of its rhythm? Let us return, for a moment, from the inner world of the mind to the outer world of things, and to the most fundamental and precise clocks that we have ever learned to build. In the deep quiet of a room, you can sometimes hear it, a very faint, high-frequency hum emanating from the electronic devices around you. It is a sound that is so constant, so much a part of our modern soundscape, that we usually do not notice it at all. But it is there, a testament to the incredibly stable and rapid rhythms that lie at the heart of our technology. These rhythms are generated by some of the most precise and reliable timekeepers ever created. Clocks that rely not on the grand swing of a pendulum or the slow turning of the earth, but on the invisible, perfect heartbeat of a tiny, shimmering crystal. To understand this, we can picture the inner world of a simple quartz watch. If you were to open its casing, you would not find the intricate gears of an old mechanical timepiece. Instead, you would find a small battery, a microchip, and a tiny metal can. Inside that can is the heart of the watch, a sliver of quartz crystal, precisely cut into the shape of a miniature tuning fork. This crystal is the source of the watch's remarkable accuracy, and it works because of a wonderful property of matter called the piezoelectric effect. Piezo comes from a Greek word meaning to press, and the effect is simple. When you physically squeeze or bend a quartz crystal, it generates a tiny electric voltage. The reverse is also true. If you apply a voltage to the crystal, it will bend or deform. The microchip in the watch uses the battery's power to send a pulse of electricity to the quartz crystal, which causes it to bend. As it flexes back, it generates its own little pulse of electricity. This feedback loop, happening over and over, causes the crystal to vibrate, to oscillate back and forth, at an incredibly fast and exquisitely stable frequency. A typical watch crystal vibrates exactly 32,768 times every second. The microchip is designed to count these perfect, crystalline heartbeats, and for every 32,768 vibrations, it advances the second hand by one single tick. This method of timekeeping is astoundingly precise, but human ingenuity has pushed the search for the perfect rhythm even further, down to the level of a single atom. The official, international definition of 1 second is no longer based on the rotation of the Earth, which we have learned actually has tiny, unpredictable wobbles and variations. Instead, the second is now defined by the atom. An atomic clock, the most precise timekeeping device ever created, works in a similar way to a quartz watch, but instead of a vibrating crystal, it uses the natural, unvarying vibration of an atom as its pendulum. Specifically, a second is defined as the time it takes for an atom of the element, cesium-133, to oscillate between two specific, low-energy states, a total of 9,192,631,770 times. This quantum leap within the atom is a perfectly stable and universal constant of nature, the same here as it is anywhere in the cosmos. These atomic clocks are so breathtakingly accurate that they would not lose or gain a single second in over 300 million years. As we lie here, it is a moment to feel a quiet sense of awe for this human journey with time. We began by measuring time with the shadow cast by the sun and the slow drip of water from a vessel. We then learned to capture time in the mechanical rhythm of swinging pendulums and vibrating springs. And now, we have learned to measure its passage by the quantum heartbeat of a single, invisible atom. We have, in a sense, built a clock that is more stable, more reliable, and more perfect than the very rotation of the planet on which we live. We have tamed time, measured it with a precision that borders on the divine. But this measured time is still a tool, a system for coordinating our lives, a grid we lay over our experience. Is it possible, then, to step outside of this grid? Is it possible to step outside of time altogether? That very question, whether it is possible to step outside of time altogether, might seem like a fantasy from science fiction. And yet, I believe you have already, in your own life, experienced moments of this timelessness. Have you ever been so completely absorbed in an activity that the world around you seemed to melt away? Perhaps it was while painting, or playing a piece of music, or writing, or even just being lost in a wonderful book. In these moments, the clock on the wall might as well have not existed. Hours can pass by, in what feels, in retrospect, like only a few blissful minutes. The constant, chattering narrator in our minds, the one that is always worrying about the future or ruminating on the past, grows quiet. There is no room for it. There is only the task at hand, only the colour flowing from the brush, the notes rising from the instrument, the story unfolding on the page. In these precious moments, we are free. This profound experience has a name in modern psychology. It is called a flow state. It is a state of optimal experience, where we are so immersed in what we are doing that our sense of self, our ego, seems to dissolve. We merge with the activity itself. And one of the most common and powerful characteristics of a flow state is this profound distortion of the passage of time. Neurologically, it is thought that during these states of deep focus, a part of our brain called the prefrontal cortex becomes less active. This is the part of the brain that is responsible for our higher cognitive functions, for our sense of self-consciousness, our inner critic, and, crucially, for our awareness of time. When it quiets down, we stop analyzing, we stop judging, and we stop projecting ourselves into the past or the future. We simply are. We are fully and completely present. This modern scientific understanding echoes a wisdom that has been taught for thousands of years in contemplative and philosophical traditions from all over the world. From Zen Buddhist masters who speak of the eternal now, to the ancient Stoic philosophers who taught that the only time we ever truly possess is the present moment, humanity has long recognized that the key to a certain kind of peace lies in freeing ourselves from the tyranny of the clock. This is not about pretending that time does not exist, or that we do not have responsibilities in the future. Rather, it is about recognizing that our awareness, our consciousness, does not have to be a helpless passenger on the moving train of time. We can learn to step off that train, even for a moment, and simply stand on the platform of the present. We can learn to inhabit the now so fully that the anxieties of what is to come and the regrets of what has been lose their power over us. In these moments of deep presence, time does not stop, but our obsession with it does. Perhaps, then, our constant anxiety about time, our feeling that it is always slipping through our fingers, is a product of not fully living in the only moment we ever truly have, right now. We spend so much of our lives mentally rehearsing a future that will never arrive exactly as we imagine it, or reliving a past that we can no longer change. We exist in a state of self-imposed exile from the present. But here, in this quiet moment, as you simply notice the feeling of the breath entering and leaving your body, you are touching that timeless dimension of your own being. This simple, peaceful awareness is always available to you. It is the silent, still center in the midst of the ceaseless flow. We have now explored the end of time as a personal experience at the edge of a black hole, and the end of time as a psychological experience in the stillness of the present moment. But what about the end of time for the universe itself? What does the ultimate, distant future hold for the cosmos? Let us travel now in our imaginations to a time so impossibly distant that our minds can barely grasp it. The journey to the very end of the universe's long story. The last star in the cosmos is dying. For trillions upon trillions of years it has shone, a final, lonely beacon in an ocean of ever-expanding darkness. But now, its fuel is spent. It swells one last time, and then, with a final, silent sigh, it fades into a cold, dead ember. What does it see? It sees nothing. For with its fading, the great age of light in our universe has finally come to an end. We are now in the deep, cosmic twilight, an era of profound and unending emptiness. The galaxies have long since receded from one another, carried away by the relentless expansion of space until they have vanished beyond each other's cosmic horizons. The great, swirling cities of stars are gone. All that remains in the vast, cold and silent expanse are the scattered remnants, the ghosts of what once was, cold brown dwarfs, dead neutron stars, and wandering, frozen planets, all drifting aimlessly through the near-perfect vacuum. This theoretical vision of the far future is known as the heat death of the universe, and it is the ultimate, logical consequence of that powerful law we encountered earlier, the second law of thermodynamics. It is the final victory of entropy. As we learned, the universe is constantly moving from a state of order to a state of greater disorder. In this far-flung future, that process will be nearly complete. Entropy will have reached its maximum possible value. All of the useful energy in the cosmos, once concentrated in the fiery hearts of stars, will have radiated away and spread out, distributing itself perfectly evenly throughout the infinite void. There will be no more hot places and no more cold places, No more bright spots, and no more dark spots. There will be only a uniform, and unimaginably cold, equilibrium. And in a universe where the energy is perfectly spread out, where there are no differences in temperature or pressure, no gradients, no work can be done. All interesting processes must cease. The engine of the cosmos will have finally run down. Nothing will happen. And in a universe where nothing happens, does time itself still have meaning? The arrow of time, as we discovered, is the arrow of increasing entropy. But when entropy has reached its maximum and can increase no further, the arrow has nowhere left to point. Time, in a meaningful, directional sense, may simply cease to exist. Even the most resilient objects in this future, the supermassive black holes that once sat at the center of galaxies, will not last forever. Through a strange quantum process known as Hawking radiation, they too will slowly, painstakingly, evaporate over timescales that make the current age of the universe seem like the blink of an eye. They will leak their mass and energy back into the void until they too are gone. And then there will be only a vast, cold, thin soup of elementary particles, drifting ever further apart in the eternal darkness. This vision can sound terrifying, a story of ultimate and final desolation. But perhaps we can see it another way. As you rest here, feeling the warmth of your own body and the life that flows within you, you can see this end not as something to be feared, but as the universe finally coming to rest after its long, 14 billion year journey of frantic and beautiful creation. It is the universe achieving a state of perfect and final peace, a quiet and profound stillness after the sound and the fury of its cosmic story. Is this an end, or is it a kind of cosmic meditation, a final, silent exhalation? We have journeyed now from the first quickening beat of a human heart to the final, silent stillness of the cosmos. After all of this, after seeing time as a river, a story, a dimension, and an arrow, what can we say is the true nature of time? Have we found a final answer? After such a long and winding journey, from the intimate rhythm of a heartbeat to the final, silent stillness of the cosmos, we are left with that ultimate question: what is the true nature of time? Imagine, for a moment, that a child, with all their clear and simple curiosity, turns to you and asks, "What is time?" After everything we have explored, how would you even begin to answer? Perhaps you would start by speaking of the body and the quiet river of rhythm that flows within us, our own personal clock that anticipates the dawn. Or maybe you would speak of the mind and describe time as a great and dusty library, where the stories of our past are stored on endless shelves and where our perception of an hour or a day can stretch and shrink with our emotions. You might try to explain it with physics, speaking of a great, flexible fabric of space-time, a fabric that can be warped and deepened by the gravity of a star, causing time itself to flow like a slow, deep current. Or you might offer the image of a shattering teacup and explain that time is an arrow of increasing disorder, a one-way street that separates what has been from what will be. Perhaps you would even whisper of a quantum world, of a garden of forking paths, where time is not a single line but an endlessly branching tree of possibilities. Each of these answers would be true, and yet each would be incomplete. Each metaphor we have used on our journey, the river, the library, the fabric, the arrow, the tree, is a partial truth, a single facet of a magnificent and complex jewel that we can never seem to see all at once. Our journey has shown us that time is not one thing, but many things. It is biological, woven into the very fabric of our DNA by the turning of our planet. It is psychological, a story our brain tells itself, a narrative it constructs to make sense of the stream of sensory information. It is geological, a vast and patient story told in the slow layering of rock and the wearing away of mountains. It is cosmological, written in the ancient light of distant galaxies, a message from the deep past. It is relativistic, a personal and fluid dimension that quickens and slows with our every movement through space. It is thermodynamic, a consequence of the universe's slow, inexorable slide from order into chaos. And it may even be quantum, a granular, ticking reality that proceeds in a series of impossibly tiny, discrete steps. The simple, and perhaps humbling, truth is that there is no single, unified, scientific theory of time. Our two greatest theories of the universe, general relativity and quantum mechanics, actually describe time in fundamentally incompatible ways. Physicists around the world are still searching for a deeper theory that might unite them. Some modern thinkers, like the physicist Carlo Rovelli, have even come to the radical conclusion that time, at the most fundamental level of reality, may not exist at all. In this view, time is not a primary ingredient of the cosmos, but an emergent property, something that arises from the complex interactions of more fundamental processes, much like the way the property of wetness emerges from the interactions of countless individual H2O molecules, or the way a traffic jam emerges from the behavior of individual cars. The universe, at its core, may simply be without any special dimension of flow. And what we call time is a feature of our macroscopic, thermodynamic, and biological perspective. So where does that leave us? Perhaps it leaves us in a place of profound and beautiful humility. Perhaps the goal was never to arrive at a final, neat definition that could be written in a textbook. The true nature of time may not be a puzzle to be solved, but a mystery to be lived. Its power and its beauty may lie not in being pinned down and defined, but in being the vast and invisible canvas upon which all definition, all change, all life, and all experience is possible. And so, after our long journey through the stars and into the heart of the atom, we find ourselves back where we started, in the quiet of a room, in the simple presence of our own being, listening to the gentle, ancient rhythm of our own breath. With all that we have seen, what have we learned that we can carry with us into this quiet and simple moment? Let all of those vast and complex ideas gently dissolve, like sugar in warm water. Let the stars and the black holes and the quantum uncertainties fade into a soft and distant background. And bring your awareness, just for a moment, to the simplest and most immediate reality you can ever know. The gentle, physical sensation of your own breath, entering and then leaving your body. This is it. This is the only moment. It is not a theory, or a metaphor, or a philosophical puzzle. It is real. Feel the slight coolness of the air as you breathe in, and the gentle warmth as you breathe out. Feel the subtle rise and fall of your chest or your abdomen. This simple, recurring rhythm is your anchor in the great, mysterious ocean of existence. It is always here, waiting for you to notice it. Let your awareness expand from the breath to the simple feeling of being here. Notice the gentle weight of your body, the feeling of the surfaces that are supporting you. Notice the temperature of the air on your skin. Listen to the quiet sounds of your environment, the distant hums and whispers of the world, and simply allow them to be as they are, without needing to name them or judge them. In this state of simple, open awareness, where is the past? It is only a thought, a memory arising in this moment. And where is the future? It is only another thought, an image of anticipation, also arising in this present moment. The only thing that is ever truly real, the only place where life is ever actually lived, is in the gentle, shimmering, and ever-present field of right now. This is perhaps the greatest and most useful lesson from our entire journey into the nature of time. We have seen that on the grandest and smallest scales, time is a strange, wild, and paradoxical thing. But for us, as human beings, the truth is much simpler. The past is a story we tell ourselves, a story that can be a source of wisdom and joy, but also of regret and sorrow. The future is an act of imagination, a realm that can hold our greatest hopes, but also our deepest anxieties. We cause ourselves so much suffering by mentally living in these two unreal places. But our journey has shown us that the now is more than just a fleeting moment. It is the stage upon which all reality unfolds. The block universe may suggest all moments exist at once, but our consciousness only ever illuminates one slice. The many worlds theory may suggest infinite branching futures, but we only ever experience our one, present path. The storyteller in our skull may weave past and future into a seamless narrative, but the raw material for that story is always the sensory input of this very moment. Time is not something we have, but something we are. We are not helpless passengers being carried along by the river of time, In a deeper sense, we are the river. Our existence is the very unfolding of time itself. To be alive is to be a process, a rhythm, a constant becoming. And so, the true nature of time may forever be the universe's greatest secret, but the greatest gift of time is the profound and simple beauty of the present. It is the only gift we are ever truly given, and it is given to us in every single breath. Let us cherish it. Thank you for joining me on this long and gentle journey tonight. I hope it has brought you some comfort, some wonder, and perhaps a deeper sense of peace. If you have any thoughts on time that you would like to share, I would love to read them in the comments below. And if you have enjoyed our exploration, please do consider liking this video and subscribing for more soothing stories from the heart of science. For now, I wish you a night of deep rest and sweet, peaceful dreams. Good night.